In this part, we will discuss vectors in three-dimensional space. In 3D we add the third z coordinate, and also cut it into equal blocks with a new letter k. Remember that 3D space is a three orthogonal planes: xz plane, xy plane, and yz plane. A vector resides in yz plane, will only have green and blue components. A vector resides in xz plane, will only have red and blue components. A vector resides in xy plane, will only have red and green components. In general, 3D vectors will have all components: blue, red, and green. Now we will try to represent this random vector in terms of unit vectors. All we need to do is to move from the origin toward the head of vector r, counting the number of unit vectors on each axis. This is how we represent each vector in terms of unit vectors. One other way to represent and analyze 3D vector is by knowing its cosine angles. These angles are the angles that this vector makes with the basic x, y, z coordinates. We will use the cosine of these angles to project this vector into its orthogonal components over x, y, and z axis. To do this, we will use the formula we discussed before. Let's now work out this vector. Notice that only two of the three angles are given to us. So before we start, we need to discover the third angle. The third blue angle can be found based on the trigonometric identity. Now we can project this vector into the three coordinates axis. Sometimes, vectors are represented in different way. This vector, for example, it makes 40 degrees with its shadow in the xy plane. And the shadow of this vector makes 60 degrees with the y-axis. Now we will imagine an auxiliary plane of two axes, z and u, then we will project the vector over these two axes based on the 40 degrees angle. At this stage, We just found the z component. Now we will use the component projected on the axis u, and project this component again over the x and y axis. To find x and y components, after finding all orthogonal components, we can build the rectangular representation of the vector.